Ask someone what controls their computer, and this someone is not in our industry, and they would say most likely, well, it's Windows. Yeah, Windows is the software that controls their system, but what they don't understand is before we even get to that software, when we start up a machine, there is something called firmware that is controlling the system. In this nugget, we'll dissect this firmware. It's either basic input-output system firmware, or it's a new and enhanced version called the Unified Extensible Firmware Interface. So your BIOS or your UEFI, these are critical firmware instructions that are going to really control your computer when it starts up. Now, where are they stored? They're stored in a chip that is on your motherboard. And of course, we'll be looking at motherboards in great detail next in this A+ course. And this chip is commonly called an electronically or electrically erasable, programmable, read-only memory. Now, I want to make this clear as we move throughout this class right now. You don't need to memorize things like that. The CompTIA A+ exam is so great about not making us memorize that kind of information. So you don't see a multiple choice question that says, what does EEPROM stand for, or anything like that. So we just recognize EEPROM, or I do, as a longtime worker with these machines, and I don't need to even memorize what that means. So the programs are stored in this chip. Now, how do we interact with the information in there? Well, that's with something called the CMOS setup program. By the way, you might want to know what it stands for. You won't be tested on it, but that's complementary metal oxide semiconductor. Whew, thank goodness we don't have to memorize those kinds of things. So here you can see the little CMOS chip, and it'll famously have a battery that is powering it. And this setup program is how we can interact with the BIOS stored on this chip so that we can change the behavior of the system, or maybe we want to run some diagnostic testing of the system. Maybe we want to monitor things like temperature in the device, or check out the fan speeds and make sure they're working properly. Now, when we make changes in here, though, those changes need to be stored somewhere, and they're stored in another chip called the NVRAM chip. That stands for non-volatile RAM, and this is kind of interesting, this verbiage, because non-volatile means it won't change. So non-volatile RAM means that if the thing loses power, those settings will be saved. We'll have a nugget on RAM, random access memory, and this is where stuff is stored that you're working on your PC. And the problem with RAM is if the PC loses power, you lose everything in RAM. So this is special kind of RAM that can retain its information when there is a power cycle. I've just thrown a lot of information at you, and I understand that. Take it easy. Remember, you can watch this again, and you can review it as many times as you need to. And I'll also make sure you've mastered all this information based on the flashcards that you're going to be going through that go along with this chip. With this chip. I was just looking at a chip, so I said chip. That's great. With this particular course. All right, so let's talk about something here. This BIOS or this UEFI that live in this EEPROM chip, these things could need to be updated. Maybe there's a bug with your PC. Maybe there is some new big hard drive that you would like your PC to support, but it can't do that without an upgrade of the BIOS that lives here. When we upgrade our BIOS, this is called flashing the BIOS. And so you can think of this as like the equivalent of installing a new software operating system. Like that's what we could do to our machine. We could put a new version of Windows on it. Here, though, we're dealing with firmware, so we like to call it flashing the system. I think it's also called this oftentimes because we will type a command often when we do this called the flash command. So, engineers just started calling this flashing the BIOS. So how do you get this new BIOS program? Well, It depends. It's going to vary from manufacturer to manufacturer. Here's an Alienware Aurora R4, a PC that you'll meet later on in these nuggets up close and personal. But notice I've gone to the Dell, who now owns Alienware. I've gone to their support site, navigated to the product support for this particular program, and if we scroll down, we'll see there is a BIOS update. And we can run this program, download the file, of course, and run this program and upgrade the BIOS to version A11. Now, sometimes it won't just be a file we can download and run in Windows. We might have to put it on a little thumb drive, one of those USB thumb drives, and boot the machine from that thumb drive to execute the BIOS upgrade. And you may be wondering, how in the world could I boot a machine to a little thumb drive? And we'll be showing you how you would do that in this nugget. But I know the big question you have: how do we get into the CMOS setup so that we can make changes to how the PC behaves, so we can modify the BIOS settings? Well, here we have a virtualized machine right here. This is an Ubuntu operating system, a Linux box that I use. And if I restart it, we'll be able to see that boot process. Now watch closely, because it's going to just appear very briefly at the bottom of the screen. F2. Oh, it happened so quick we could barely see it. It said F2 there for a split second would allow us to enter setup. So what I would do is I would reboot this machine holding the F2 key, and that would trigger us getting into the CMOS setup utility so that we could manipulate the BIOS. So here we are. I have restarted that machine, and I was quick like a bunny, and I hit the F2 key, and I did enter what they call the Phoenix BIOS setup utility. You'll see this with a different title. Many times you'll see it as the CMOS setup utility. And this is how we can do all kinds of cool stuff in the BIOS of the system. The first thing we notice is we are not going to be using our mouse. No, we're going to be using our keyboard. And the commands on the keyboard that we would use are shown down here. For instance, press F1 and you would get help. I've never done that before in my life. What I do is I go the up and down arrows to move up and down in here, the left and right arrows to select things, the plus and minus to change values, the enter to go into a submenu. To quickly get back to the defaults of the BIOS, you would hit F9, and F10 would allow you to save and exit. Now you notice there are these tabs across the top. So if I hit the right arrow key on the keyboard, I move between those tabs of information. So exit, like exit saving changes, can be done here on this exit tab. Load setup defaults, and remember we actually have keys that would do that same thing, but I typically like to move to this tab and then arrow to what I want to do. Maybe I've made changes and I want to save those changes. So one of the things that we see right away is that we can confirm component information through the BIOS. We can confirm the RAM. Right on this screen, let me grab my pen, we can see information about the system memory and the extended memory that are installed on this device. We can see information about the hard drives. And this is a virtual machine, so it just shows my primary master as the CD-ROM. The hard drive itself is actually some magic we're doing in virtualization, but you get the idea. We're going to be able to get information about the RAM, the hard drive, the CD-ROM drive, also called an optical drive, the CPU, and that's one of the reasons that we love the BIOS, is to use the setup utility to go in and examine information about the components that are installed in this machine. Now, the big thing though with the BIOS, the biggest thing that I want you to understand about it is the reason we most often enter it here, and that is for the boot menu options. So if I go over to boot, notice it says here's the order that we will boot this device from. And what it means by boot really is it's looking for a program to run. It's looking for Windows, let's say. So what's the order we want it to look through the different devices where Windows could be if we were running Windows? So is it going to be removable devices? Is it going to be a hard drive? Is it going to be a CD-ROM drive? And we can move the order, the boot order that it looks. So if we had a flash thumb drive with a little program like the BIOS update that we need it to boot from first, we would make sure removable devices is at the top of the list, just like you see here. Then it would go to the hard drive if it saw nothing there. Then it would go to the CD-ROM. So in the case of the CD-ROM being listed first, and you don't have a CD-ROM in the drive for it to boot from, it would look there, fail, and then go to the hard drive. So we can speed up the boot process by choosing the device that we're going to boot from first that makes the most sense. Something else we can configure in the BIOS is to enable or disable particular devices. We might control the date and the time settings in here. We might control certain device like clock speeds potentially. And something else that you'll often see in the BIOS, it will usually be under advanced. It will be the option to allow virtualization. It'll specifically say like Intel virtualization support or something along those lines. This is very important because if you want to allow this device to run other operating systems in a virtualized manner, you have to enable this support in the BIOS. Specifically, it'll say Intel virtualization technology on most devices. So you would go in and make sure that's enabled. If you don't have it, it might mean, sure enough, that you can't virtualize devices. And I've got some newer PCs that don't allow virtualization, so you wouldn't have that option here. Then notice there are security settings that we can set in the BIOS, and these are going to vary, again, based on what kind of BIOS, what kind of PC that you're working with. But notice here, we could set a supervisor password. So we could password protect coming in here and monkeying around with these important settings. We could even set up a password that is required on boot of this particular device. Wow. So before the computer will even start up, we could have a password entered. You might wonder, what would happen if you ever set this incredibly powerful password on your computer and then you forgot it? Well, you'd have to open up the case on the computer and you'd have to go in and like remove the CMOS battery or use some jumper settings so that you physically override the requirement of this password in that case. I wanted to elaborate on BIOS security with you. We certainly saw that passwords could be set in my case, but realized that you could also work with the BIOS in order to make sure that the drive is encrypted. How cool, so that if someone were to try and read the contents of the disk drive in your system, they cannot. A great example of this is in Windows, and it's called BitLocker. So BitLocker allows you to give this great encryption to the entire drive, helping to protect the data that's on it. There's also such thing as a TPM chip that your system might support. What this does is it makes sure at boot that there's been no tampering with the drive. So your Windows drive has been really left intact and just the way it was when you shut down the system the last time. With TPM chips, you can also use like a PIN number that needs to be known at startup as well. For mobile devices like laptops, you might have a low jack installed where you can literally find or maybe even disable the mobile device if someone were to mess with it. I think there's a low jack for the car, isn't there? And that's where they got this idea. And then finally, your system BIOS may be enabling you to do secure boot. This is very similar to a TPM chip type approach, where the device can literally check the system files and things of that nature to make sure that there's been no tampering with them before the device is enabled for boot. Now, I'm sure like me, you're super excited right now that this BIOS exists on your system and is controlling things for you, and you now know how to go in and control it. And let me give you some more good news. The BIOS will do for us built-in diagnostics on your system. It's called the POST. P-O-S-T. It stands for Power On Self-Test. So when you punch that power button on your machine, it will start checking things and making sure everything is okay. If it's showing you information on the screen and you can control whether or not it shows you information in your screen, that's one thing, but it will do something else too. It will emit beeps. So you will hear these beeps from your computer as it starts up. You can check with your manufacturer for what a particular beep code means. And I'm not making that up. A beep code refers to the number, the duration, the pattern of the beeps that you're hearing at startup. You'll know yourself what the normal beep sound should be, because most of the time we get lucky. Well, it's not luck, it's how the machine's supposed to work. It boots perfectly and everything inside it is just fine. So you'll begin to recognize what the normal beep sound is like, and when you hear something different, you'll know to investigate what that beep code is telling you. Now, there's one last thing I want to tell you about our beautiful BIOS, and that is that it can be a key for us monitoring the health of our system. What can we monitor? Well, here's a big one: temperature. My beautiful Alienware Aurora system all of a sudden would turn itself off. I'd be right in the middle of flying my Microsoft Flight Simulator. I'm doing an instrument landing at Seattle SeaTac Airport. I'm just about to touch down. Bloomp! The computer turns off. Good thing my passengers didn't see this. This was a real problem, and discovering it, exactly why it was turning off, was great, because I was able to go into my BIOS and watch the temperature rising dramatically, and that was because the intense liquid cooling system on this really expensive PC was not functioning properly. So we can monitor things in the BIOS, and that's great. The fan speeds. Maybe if your case has security on it, you can see if someone is open the case with what's called intrusion detection. The voltages running through your device can be monitored. Of course, the clock settings and the bus speed. The bus speed is basically referring to how fast things can be communicated in the circuitry of the computer. There's a bunch of different buses on the motherboard, and they're going to dictate how fast stuff can move from one component to the other, and these speeds can be monitored. Many of these things could even be altered in the BIOS, as we know, but of course right now we're focusing on the monitoring capabilities that we have with this powerful firmware on your system. So what do you have on your PC, a BIOS or this newer UEFI? Well, you and I really aren't too concerned about this for the CompTIA A+ exam, but if you are interested in reading more about the new UEFI, just head up to my blog at ajsnetworking.com and go over to the categories and choose the A+ category, and you'll see in that category I have an article for you that I wrote called UEFI, the Unified Extensible Firmware Interface, and you can find out things like why did they move to this from the basic BIOS, and you'll read that they wanted to make things faster, more secure, and provide support for some of the latest, greatest technologies that a PC can have. Boy, we covered a lot of information together in this nugget, didn't we? And occasionally, every now and then, you never know when it's going to happen. That's why it's called a pop quiz. We're going to have a pop quiz. It's pop quiz time in this nugget, and we need to flash the BIOS of our machine to support a new capability and to fix a known bug. You need to first boot to a thumb drive. How do you do this? A, edit the boot first Windows setting. B, change the boot order in the Windows safe mode. C, edit the boot sequence in the BIOS, or D, you can only boot first to a hard drive? Well, after the knowledge that we possess from this nugget, this pop quiz question is easy for us, isn't it? Sure, we are going to edit the boot sequence in the BIOS. We, of course, do that with the CMOS setup utility that we utilize together in this particular nugget. Is this representative of something that you might encounter in your actual CompTIA A+ exam? It sure is, but they wouldn't show a picture of a thumb drive. Too bad, because that's really funny. And I don't know if they actually sell one that looks like that, but if they do, I'm going to go out and buy one right now. So in this nugget, we discussed your BIOS or your UEFI, and we know how it's firmware that's going to control your system, and we know all about it. We know how to manipulate it, use it for great things like diagnostics checking and monitoring of your system and changing the boot order. And I sure hope you found this nugget informative, and I'd like to thank you for viewing.